Hello, and welcome to the YouTube channel for the Northeast Risk Management Network. In case you're not familiar with RISC already, the RISC part of our name is an acronym for Regional Invasive Species and Climate Change. We are a collaborative network of researchers and practitioners with a common interest in reducing the compounding effects of invasive species and climate change. If you want to learn more, I encourage you to visit our website at riscnetwork.org. That is riscc network.org. One way that we work to strengthen the scientist-manager relationships is to provide summaries of current research on invasive species and climate change. The goal of these summaries is to translate academic research into useful and actionable information that anyone working with invasive species or climate change might be able to use. We're expanding our summaries into the realm of online tools, and we have a selection of online tools that may also be useful for managing impacts of invasive species and climate change. So the videos in this series will be supplemental to our tool summaries, which are available via our listserv or the website. In these videos, we're going to provide a short demo of how the tools work, and we'll walk through one or more of the items that we've listed in the Things to Try section of our tool summaries. Also, you can see all of our research and tool summaries on our website. There will be a link in the description of the video, and you can get notifications of new summaries by joining our listserv. Really quickly, a bit about me. I'm Mike Nelson. I started working with RISC in the fall of 2019 when I joined the faculty at the Department of Environmental Conservation at UMass Amherst. My research on invasive species has, well, I've worked with reed canary grass in the Midwest, and I've worked with sudden oak death pathogen, Phytophthora ramorum, which is a pathogen, invasive pathogen that causes rapid death in some species of oak and tan oak in California and Southern Oregon. So I have a lot of research interest in invasive species. But let's kick off this tool series taking a look at Climate Voyager. In this video, I'm going to give a quick demo of the Climate Voyager tool. So Climate Voyager is a great tool for visualizing potential future climate scenarios. The first thing to notice when you go to the Climate Voyager homepage is that navigation is via tabs on the upper right. So for example, when you hover over the tabs, it brings up a pop-up menu that shows the various subpages you can visit. For this demo, we're going to focus on the minimum temperature thresholds option underneath the temperature tab. When you open up one of the climate option tabs, the first thing you're going to see is a map of the historical values of whichever climate variable you're looking at. So in this case, I'm looking at the historical number of days that have a minimum temperature below freezing. So basically the number of freezing days in a year. I can change the temperature threshold. They have some options here, so I can change it to the number of days below 15 degrees. But let's keep it at the number of freezing days. So to navigate the map, you can grab with your mouse cursor and move to drag if you want to pan the map. If you want to zoom in, you can use the plus or minus buttons here. And finally, when you've found a region that you want to examine in more detail, if you click once on the map, it will bring up the specific number value of the variable for the place you clicked. So in this case, I clicked on somewhere in Washington County, Vermont. It also brings up a time series plot down here, which shows the projected number of days below the temperature threshold for 20-year increments all the way up to 2099. You'll notice that there's two series in each, and that's because Climate Voyager presents output for models from two different carbon emission scenarios. One is the reduced emissions scenario, and one is the high carbon emissions scenario, which is carbon emissions at the current levels. The next thing to do in Climate Voyagers, so we're looking at the minimum temperature thresholds, but we're interested in how this value might change. So if we want to look at the projected change, click on this button here, and it will reload the map, and it'll show you the change that is projected in number of freezing days. And so, as we described in the tool summary, it shows you 3 different maps, which gives a range of the outputs of the various models that form the ensemble. And so we can concentrate for now on this mean value. And this shows in the view we have here that this area in Vermont is expected to have about 23 fewer days below freezing for the time period 2020 to 2039 versus the historical observed. So we can change the window that we want to look at. Let's look at end of 21st century. So here we expect to see 71.2 fewer days below freezing in Vermont. So note that this view, the projected change, is not the absolute number of days below freezing. It's the change versus historical average. If we want to look at the actual number of predicted freezing days, we can click on this projected average tab. And so this is just the sum of the historical observed and the projected change. One of the things that we listed as a task to try to do in our tool summary was to look at how USDA hardiness zones may change for your area. So let's go back to this tab up here, the temperature tab, and we're going to go to the plant hardiness zone series of maps. And so I'm going to choose to focus in on Massachusetts because that's where I currently am, and I'm going to focus in on the western part of the state here. I live in Amherst, which is right about here, so this looks like a good map focus area. So we see now Amherst is about here. We're currently classified as Zone 6A. So let's see what we're projected to be in the next 20 years. So the possible changes produced by the ensemble of models is anywhere from 6A, so remaining in the same zone. The mean of the various model outputs is 6B, and then the highest likely outcome is 7A. And that is under our current levels of carbon emissions. So let's look at the reduced levels of carbon emissions, see if that changes anything. So it doesn't change anything, in part because it's 2020 to 39, which is a time period that we're already in. But let's scoot forward in time to the end of the century. And here we see we've gone up more. So our lowest likely outcome, we're still in 6A, but the mean outcome now is we're expected to be up in 7A, and possibly 7B. And that's at reduced levels of carbon. So let's look at the current levels. So we may very well be in Zone A at the end of the century, which just for reference is the zone that most of Western Oregon is in. So this has just been a really quick example of some things you can try with the Climate Voyager site. Obviously, there's a lot of different functionality on it. It can be useful for looking at a lot of different things. We didn't look at the precipitation at all, but another climate variable that they do include is precipitation. So one thing that might be interesting to look at is to compare whether both the temperatures are expected to increase and how the precipitation will vary. So maybe if both increase, we might expect to see not a huge increase in drought stress, but if temperature goes up, precipitation goes down, we might expect to see more drought stress in our area. So they do have a drought tab on here, but it looks like they haven't quite implemented this yet. So it'd be worth checking back to Climate Voyager if you're really interested in drought in particular to see if this gets implemented anytime soon. So I hope this has been a useful intro to the Climate Voyager site. There's a lot to do here, especially with these time series plots could be really informative for management in a particular area. And obviously the maps are great at looking at large-scale geographic changes in climate.